Broken hearts that you collect. Got more ice on you than Tiffany's.
Fall 2022, chapters 9 and 10. Now, this is just the test from Fall 2022. The test that you guys are going to take is going to include more homework questions, so don't only study this test because there's other questions going to be added in. All right, in a clinical trial, 27 out of 841 patients taking a prescription drug. How should we do this? Let's do it like this. Let's say A, check the conditions, and then what I'm gonna do, I had an idea of going insert table with 3, and we'll just say condition 1. Does it say it's a simple random sample? I don't think it says it's a simple random sample, so we'll say it's reasonable to assume that the 841 patients are in SRS. Number 2, this is about the proportion, because I see percentages and I even see X out of N here. So the formula would be N times P naught. So what's N? 841 times P naught. Let's do this maybe on Desmos. What's P naught? 0.027. Make sure you know how to convert that to a decimal, right? Or why don't we say this? Insert equation. Let's just say 841 times 0.027. 1 minus 0.027. I should have just done it here from the get-go. 22.09. I should have just done that on Desmos from the beginning. But anyway, here we get that. So we could say that this is greater than or equal to 10. Satisfied. Alright. 320 times 841 equals what? 41 is 16,820. So 16,820. So we have to say there are more than 16,820 patients. All right. Let's see. In a clinical study, patients taking a prescription drug. 27 out of 841 patients taking a prescription drug daily. Okay. There are likely, let's say, likely. It's reasonable to assume that there are more than 16,820 patients taking prescription drugs daily. Those are the people that we are sampling. Those are the conditions. Okay, that's A. State the null and alternative. Okay, B. Let's just say B. If you want to be super fancy, just, you could always do this. If you want to be super organized, Control C, Control V. State the null and alternative hypothesis. Now, how will I do this? I think, well, we know that it's this number, 2.7%, so watch how I'm gonna do it. Insert equation H subscript 0. See, P equals, is it capital P or lowercase? Lowercase p is fine. 0.027, and then the alternative hypothesis, well, I can't do it, so I'm just gonna press done. And then maybe below that, or to the right of it. Let's go to the right of it. H, oops. Let's copy this. Control C, paste. Control V, edit. Well, I forgot that I should probably have figured out what the alternative is. So let me press done. Let me go here and look. More than? More than? I think more than, yes. So we'll go in here, edit, change it to greater than. There you go. There's your B. C. Define the parameter where P is the proportion. Forgot the word population. Population proportion. Dang, gotta figure out what the population proportion is. More than 2. Of this drug's users experience flu-like symptoms. Population proportion of people taking this drug that experience flu-like symptoms. That's the hard part. You have to figure out what the population parameter represents. You can kind of see it by, looking at the questions and things. Okay. D. Find the p-value. Okay, we could do that. For the p-value, There's two ways to do it. We could use it, the normal calculator. Let's see, p hat. If you don't want to be fancy, just type p hat. What is it? What is p hat? It's 27 over 841. Well, let me go over here. 27 over 841 equals that, right? Well, I'm just gonna leave it as a fraction actually. Just say p hat equals 27 over 841. If I want to be organized with my work, I could say p0 equals to, notice I'm not being fancy there. If you want to be fancy, put a subscript of 0. But I'm going to put 0.027. And I think that's all I need, right? For my p-value, the p-naught, oh, standard error. That's right. Standard error stuff. Okay, so standard error, I'm going to do this. Oh yeah, here we go. It's like this, square root fraction 0.027 1 minus 0.027 over, was it 841, I think. There's my standard error. Great. Control C, Control V, Control C, insert. How fancy do I want to be here? Let's see, sigma, where's sigma? Subscript p hat, right? P hat. Make sure you move right arrow to bring the equation out from the p. And let's see if I can plug that in. Yeah, I can. There we go. Standard error. Great. And from here, I have everything I need. I got my standard error, I have my mean, and I have my p hat. Those are the three things I need for the normal calculator. So let's see if I could do this. For the standard error, I have it on Desmos. I have the number right here. Control C. So let me go to stat calculator normal. Control V. 0.027. 27 over 841. Now if I press compute, that tail's too big, so I'm gonna flip it. See, that's a tip, so I'm gonna change it. Boom, smaller tail. I need the smaller tail. Is it a two-tailed test? If it's a two-tailed test, I'll double it. I don't think it was a two-tailed test, so that's my p-value. Therefore, I could screenshot this, can't I? Okay, part E is to state the conclusion, technical and non-technical. Let's do it. Reject. Oh man, we're failing to reject. Fail to reject h naught since p-val is greater than 0.05. I'm assuming it's 0.05. Yes, it is. It says it right here. Great. Okay, and then the next part, there's insufficient evidence to conclude that the population proportion of users of the drug experience flu-like symptoms is more than, right? More than 0.027, because that's the alternative hypothesis, more than 0.027. Notice how I borrowed this language. Proportion of people taking the drug that experience flu-like symptoms. Proportion of people, users that experience flu-like symptoms. See how I just kind of borrowed the part C, the parameter. All right. F, describe a type 1 error. Well, this should say type 1 or type 2 error, because in this case it's a type 2 error. So we're gonna say for F, we'll say type 2. We'll say, let's say this, possible type 2 error would be concluding that, now this is accepting a false null. Accepting a false null. Concluding that, okay, the proportion of drug users who experience flu-like symptoms is 0.027 when it is actually higher. Because we're accepting a false null. The null hypothesis is false. If it's false, that means it should be higher. The alternative says that it's higher. So it's actually higher but we're concluding that it's only 0.027. That's it. Question number 2. All right. In a recent study, blah, 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 we have mean. Okay, so I don't even need to read the question. Wow, this, how nice of me to give you X bar and S. Jeez. I'm just spoon feeding you this question, it looks like. I have 18, that's N. This must be mu sub 0. Okay, so okay, great. So watch. A. Extra credit, check the conditions. It's not extra credit, by the way, for you guys, because I love you guys that much. If you, I don't know, did we like inserting that thing? I guess so. Table 3 conditions. 1. Does it say it's a simple random sample? Well, where's the sample? The researchers randomly selected 18 adolescents. You see that? So the 18 adolescents are randomly selected. 2. Ooh, the sample size is low, only 18. Therefore, we need this. Boom, the sample data revealed. Okay, so we could just say this. No outliers. There you go. Control C, Control V. Just say the sample data revealed that the hippocampal volume is approximately normal with no outliers. I mean, if you want to be really, you know, smart or whatever, you would say this is needed since the sample size is less than 30. 3. 20 times 18 equals 360. There are more than 360, whatever the population is. What's the population? We randomly selected adolescents with alcohol use disorder. Okay, there are more than 360. Watch this, just copy. Adolescents, there you go. Copy that, Control C, Control V. You could say there are more than. It's reasonable to assume that, if you want to be fancy. It's reasonable to assume that there are more than. Okay, now B, state the null and alternative. Okay, let's do it. B, be organized and do stuff like this. Control C, Control V. All right, now if you want to be fancy, you get the equation editor and you do H with the subscript of 0. If not, you just do H0 like that, right? Now, if you want to be fancy, go get the Greek letter. If not, just put mu. If you're in a hurry, right? Just type it out with mu. Otherwise, do the other way with the insert equation and grab the Greek letter mu. Where's mu? See, if you want to use the letter mu, you could do that. Whatever, do what you want to do. If you want to try to impress me, then you would do that. All right. Now you may want to do stuff like this, right? You may want to say mu equals to 9.02. Get everything x bar equals to 8.05. S equals 0. I mean, this problem kind of spoon-fed you all the information here. N equals 18. So those are the 4 things: mu, x bar, s, and n. Great. So here we're gonna put 9.02, h1. Let's see. Less than. See that? I was looking for that. Less than. Okay. Less than 9.02. There's your null and alternative hypotheses. Now, for part C, defining the parameter, you could say where mu is the population mean hippocampal volumes. Control C. Where mu is the population mean, and then watch. Control V. Hippocampal volume in the alcoholic adolescents. Is it alcoholic adolescents? Let's double check. With alcohol use disorder. Got it. So everybody that we're choosing has alcohol use disorder. We're trying to figure out their hippocampal volumes. Okay. Where mu is the population mean hippocampal volume in alcoholic. Maybe we should say in adolescents with alcohol use disorder. There we go. All right. D, define. Wait, hold on. That was C. So find the p-value. Find the p-value. So for this one, we have t sub 0, right? Which is 8.05 minus 9.02, 0.7. Am I gonna remember that? Probably not. Let's see. 8.05, 9.02, 0.7, square root of 18. 18. There's our T naught. Control C. Now when you paste this, you have to use the equation editor. Equation T subscript 0 right arrow, Control V. Oops, I guess I need an equal sign here, huh? Okay. There's our T. Now we just get our p-value. For the p-value, we need this number. It's a huge number. Control C. Stat calculator T. Paste that number right here. I think this is 17. That's it. Is it 17? I think so, right? 18. Is this correct? Yeah. Small p-value, new. Anything else? State the conclusion. No type 1, type 2 error on this one? Okay, hold on. Okay, so E. Reject H naught since the p-value is less than 0.05. Let's double check that it's 0.05. No, it's 0.01. Okay. So 0.01. And then we say there's sufficient to conclude that what? That the population mean hippocampal volume of adolescents with alcohol use disorder is less than, let's just say is smaller than people without alcohol use disorder. So just put smaller. I know what you mean because it says less than. Woo, that's it. So this one doesn't ask for type 1 error. The other one did. Type 1 error in this case would be rejecting a true null. All right, you were trying to estimate the proportion of people who didn't see family for Thanksgiving. You sample 56 people and find that you have a margin of error of 15% and a point estimate of 0.62. You would like to make this interval wider. What would you recommend? To make it wider, I'm gonna increase the confidence level. Okay, is that in here? It doesn't say increase the confidence level. But I'm also gonna decrease the sample size because that's also an option. Because remember, when you increase the sample size, it gets more narrow. Therefore, if you decrease the sample size, it gets wider. If the consequences of making a type 1 error are severe, what would you use? 0.01, easy one. Clayton Kersaw, okay, we have data, yay, we have a data question. Let's do Control C. Looks like we're doing confidence interval stuff. So I'm gonna go here, paste here. And then, since I'm doing confidence interval stuff, I'm probably gonna do stat, summary stats column, get n, mean, and standard deviation, right? That's what we normally do for confidence interval stuff for the means. Confidence interval stuff for the mean, right? We need all this stuff, right? Okay, what's the critical value? Okay, that's funny because it doesn't give a confidence level. Ha. If it doesn't give a confidence level, you assume 95%, but this question should give a confidence level. So assume, okay, so watch this. So A, be organized, right? Control C, Control V. Assume 95% confidence level. Let's assume that. Otherwise, what are we gonna do? We gotta assume something, right? So stats is the mean. We don't know sigma, right? This is their sample standard deviation. So we have to do calculator T. Between, always in chapter 9 we do between. Go to 0.95. Oh, by the way, what was our sample n? Our sample size is 15, so maybe I should put 14, right? And then change this to 0.95. So there's my T star. Control C, that's my T star. By the way, maybe I should copy this because we got to show our work, right? So new. Great. So we could say T star equals 2.1448. Next one, B. What do they want? What's the margin of error? Okay. Show your work. Got it. Control C. They want the margin of error. Margin of error formula. T star S over square root of N. So I need this S. Control C. T star, watch, I gotta get 2.1448. Okay, so watch 2.1448 times S over square root of N, 18. There's your margin of error. Control C, Control V, put an equal sign here. Did I Copy that right? Double check. Wait, how did I not copy that right? Interesting. Okay. Control C. I'm glad I checked that. E equals to. There's your margin of error. And that's my work. Control C. Go over here. Insert. Equation. Control V. Done. Margin of error. Alright, what's the confidence interval? Show your work on how you got the lower and upper bound. Okay, what's the interpretation? Okay, got it. So we need the confidence interval, right? So I guess we should always do this on the test, right? Copy this, be organized, Control C, Control V. I don't know, I kind of want a little bit of space maybe. Make my stuff look a little neater. Okay, lower bound and upper bound. Let's see. What's my mean again? My mean was 94. That was my mean, right? Control C, go here, go to here. Control V, minus the margin of error. That's my margin of error. Such a small margin of error. Jeez, why is my margin of error so small? I guess because my standard deviation is so small. Jeez, what a small margin of error. Because everything is so, all the pitches are so close to, like the speeds are so close to each other. There's not a lot of dispersion. It's just strange to me. Okay, so I'm just gonna subtract such a small margin of error. Control C, Control V. That's why Clayton Kersaw sucks, because all of his pitches are so closely together in speed. Haha. Control C, go Giants. All right, see, so lower equals that, and then we could do this. Control C, Control V, take this. Change this to plus, right? Copy this. Control C, Control V, upper equals. I could do this. New. Save a lot of time. Control V. Show your work on how you got the lower and the upper. The lower is 94, upper is 95. There you go. Let's see. What's the interpretation? Control C. Control B. We're 95% confident that the population mean speed of, are these fastballs only? Is that why? Oh, four-seam fastball. That's why the pitches are so close to each other, because they're all fastballs. Duh. I thought they were all of his pitches. So 15 is the sample size. Did we use that? Did we mess up and put 18? Uh-oh, why did I put 18? So this is 15 sample size, so you'd have to redo some of the work, namely this. You would have to change that to a 5, and then that would change. So these answers are off a little bit. Basically, if you wanted to get the right answers, you'd have to do this. Watch. Control C, Control V, take this as your margin of error. Grab this. Control C, Control V, get rid of this old margin of error, which had the wrong one, and then grab this one, right? Control slightly off. You would change that, and then you would do this too. Control C. So if you wanted, to, you could always do this. Just change this to a plus. Maybe we'll do it. Just why not? Control C. Why not get the right answer? So this is right? 15 is the sample size. So then lower equals, upper equals, right? So then that should be correct. Let's copy this. Let's see. Lower, upper, boom. Easy to make mistakes, as one thing that I noticed. As I make these videos, it's so easy to make mistakes on little things, right? Let's see. 94.38. 94.35. So it changed a little bit, right? 94.38 to 94.35, 95.07, 95. Okay, it changed slightly. So there you go. We're 95% confident that the population mean speed of fastballs by Clayton, or say by Kershaw, is between 94.35 and 95.10 miles per hour. There's your answer. Done. So man, check your work. Make sure you check your work. Make sure you have the correct sample size. I don't know where, I think 18 was probably the sample size from the last question we did, and I used 18, so be careful with stuff like that. 6, 7. Okay, 2 more questions. So this test only has 7 questions. Your test might have a lot more because, like I said, I'm pulling in homework questions from the homework. This question says, confidence interval. Okay, critical value, blah, blah, blah. But 200 looks like a proportion question because I don't see any means and standard deviations, so different formulas. So, A, what's critical value? Normal calculator, right? In the last example, we used the T calculator. In this one, we'll use the normal calculator. So, 95% confidence interval, go to stat calculator normal between 0.95, 1.96. So maybe we should show our work on how we got that. So go new. You gotta show your work on everything if you want full credit. Control V. What's B? What's the margin of error? Okay, Control C, margin of error. Z star times square root of all that stuff. We use P hat now because it's chapter 9. We use P hat, by the way. Check this out. Open link in a new tab. Notice that chapter 9 formulas, notice how we have P hat here. P hat inside under the radical. Z star, that's E, margin of error. Just wanted to remind you of the announcements where we have the formulas. So Z star, we have it, 1.96. Now P hat, what is it? Maybe we want to write it. P hat equals 2. Weird that don't use that 18. 18 is irrelevant. It's the 418 that we want. 418 out of 2275. It's not, 18 is not irrelevant, but as far as the P hat goes, it is irrelevant. Great, so we got the P hat 418 over 2275. So watch this now. This is my P hat, right? Control C, 1.96, watch. 1.96 minus, no, we're looking for the Z star, my bad. So square root, Control V. I don't like how that did that, so I'm gonna do it like this. Right arrow, and then parentheses 1 minus. Control C, Control V, 2275. This worked, okay, it worked. That's the margin of error. So we could do this, Control C, Control V, maybe put an E over here, and then Control C, go back to the test, insert equation, Control V. Looks good, looks good. Okay, now C, part C is what? What's the confidence interval? Show your work. Okay. Now so P hat 418 over 2275. Okay, so watch. For the lower, it's gonna be P hat, Control C, Control V minus the margin of error, which I don't know, to be safe you may want to copy all that. I don't know, is this number really correct? Let's double check. 0.0159, yeah, 0.0159. Okay, so then this number, maybe to show our work, we'll take this one. Looks more complex, right? Control C, Control V, let's say lower, equals. And then for the upper, we can grab this, Control C, go down, Control V, change this to plus. I love Desmos, makes your work so easy, right? Control Z to undo. Control C, Control V, upper, equals. Maybe we should just screenshot this instead of inserting it into the equation editor. Let's just screenshot this. It's faster. All right, what's the interpretation? Control C. You could always make this smaller. Interpretation, we're 95% confident that the population mean what? What are we talking about? Donated blood in the past 2 years. Who are we talking about? Survey adults in a certain large country, age 18 and older. Donated blood in the past 2 years. Okay. So we're 95% confident that the population proportion, I think, proportion of people 18 or older in the country that donated blood in the past 2 years is between 0.1, let's say 1678 and 0.1997. 1997. Done. Whew. In a survey, 1,000 adults in a certain country were asked how many hours they worked in the previous week. Okay, what are we doing here? 95% confidence, flawed, blah, 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 blah. There is a 95% chance. Ooh. The mean number of hours worked by adults in this country in the previous week was between that and that. I think it's that one. Because it doesn't... Well, first of all, it also says chance, too. It does say mean, so it's not that one. It says chance and not confidence. So, yeah, it's this one. Is it last week? Does it say anything about last week? I don't think so. I think it's this one. Previous week. Everything's about the previous week, right? So it worked in the previous week, so everything's about this. But the thing is, whenever it says chance, that the mean makes it sound like the mean is varying. The mean is fixed. The mean is not the thing that's varying. It's the confidence interval, the lower and upper bounds, depending on our X bar. So this interpretation implies that the population mean varies rather than the interval. So that's about it. Good luck, everyone.